Okay, so we're transitioning to the other bigger technology that you have access to in the LibreVerse, and that's the Jupyter infrastructure. Um, and it's not spelled in the same way as Jupyter because it's actually an acronym of different pseudo acronym that of different languages that are put together. And there's a wide history behind Jupyter that I'm not equipped in order to be able to discuss right now. We've been using Jupyter within the LibreVerse for the last 7 years since we received the Department of Education open textbook pilot. And it was a critical component in terms of building what I refer to as the textbook of the future. Uh, it's expanded in scope and has transitioned from a set of computers that were actually housed at UC Davis and moved into the cloud just recently, but it has lots of power that you have access to right now. So, so what is Jupyter? Well, Jupyter is an open source project. You can download it if you want right now from GitHub. It provides the tools and standards for interactive computing. Uh, and it has a focus on sharing computational documents, and it's been exceedingly important for data science. And so data science and computer science are the two primary focuses that Jupyter is useful in order to be able to address. Uh, but it has utility in a wide variety of different fields, depending upon how you actually want to apply it. And I'll show you an example in my physical chemistry class for my upper divisional quantum mechanics course. So Jupyter has multiple facets associated with it, and it can be run in a variety of different sources. Google actually runs a version of it called Colab, which you have access to, at least in certain versions of it, and you have less control over it than you do in other platforms. But ours, we have full access in order to be able to expand and introduce new capabilities of it. There are two primary facets or things that I wanted to be able to mention in terms of Jupyter. One is the hub, and the other one is the binder. And the hub you can access on your Launchpad, which I'll show you a picture of momentarily. And the binder is a little bit more unique aspect of Jupyter that gives you the ability in order to run Jupyter code outside of the hub. And the example I'm going to be giving is embedding it into the textbook, so then the textbook is more engaging than just basically with text or images. So again, Jupyter is right here, right next to the Forge, because J is after F and before N for Nova. And I encourage you in order to take a look at that, and I'll probably pull that up real time because this is a relatively bare bones presentation of Jupyter. So I mentioned again that Jupyter is useful for computer science and for data science, and it is a formulation of, it's an environment that lets you go in and run code, write and run code, and see the results that's out there. It's actually, its name, Jupyter, comes from Julia, Python, and R as the three core components that are on there. So if you're unfamiliar with these terms, Python is really quite popular these days for scientific coding. Uh, R has been popular for a while for statistical coding and analysis off of there. And Julia is a unique system of focusing on real-time compiled products. I have less familiarity with Julia than I do with Python and R. But actually, there are about 30 different languages that Jupyter is able to host and run, including Java, MATLAB. Actually, it's Octave, not MATLAB, C++, and a range of other ones that are there. Many of the languages I have never even heard of before because I'm not in the computer science realm in order to be able to play with it. And the intent is that you can run these things all in the same environment, switching from one language to another language, and it's a convenient infrastructure in order to facilitate learning of that language, or to use that language in order to do data analysis, which is really quite constructive. This is a snapshot of actually directly from the Jupyter website, and I didn't download this Python code to upload on ours, but it essentially shows you what the Jupyter Hub looks like. In this case here, it uses a Lorentz attractor or chaos theory, and you're able to make widgets. You can run code on the side, and you can modify the code in order to be able to run that. About half of the computer science, maybe a little bit less than half of the computer science classes out there operate in what's called an IDE, an integrated development environment. This is not that. This right here is more of a scripting environment where you can come in and run a script and see what's going on, or you can write long form code in order to be able to see how it operates. So it's not useful for every computer science class out there, but many computer science classes can use these things quite constructively. Um, This is actually what I'll be showing real time. So I'm going to skip over that and just talk about the application of the binder, which you have access to. And the binder, it's better to actually just describe this by showing it to you. This right here is a book, or sorry, it's a section in my physical chemistry book of teaching quantum mechanics. This is a particle in the box. If you know about particle in the box quantum mechanics, you'll understand what I'm showing you. If you don't know what it is, it doesn't matter too much other than emphasizing that the page itself has code and it has text and it's bound together. Now, this can be put onto onto the Jupyter Hub as a Jupyter notebook page. That's basically what a notebook is. But we can actually use Binder in order to make the notebook as a page in the LibreText. Has a similar capability and such. So what you'll notice on this page here is that there is, let me, this is distracting. So there we go. You'll have the text that we normally would have on our pages, which we're going to start talking about editing of pages very soon in this fest. You have equations associated with that and all the things that we would normally have on a page, but interspersed between these images and this text have these blocks. And these blocks are binder code or binder-based Python code that's embedded into the book. And the argument behind here is twofold for why we put this together. One is it's a useful infrastructure in order to have more engaging textbook for students in order to interact with. And then from that engagement, they're able to tweak with and learn about the environment, learn about the code that you have. Let me phrase that, learn about what you want the code to address, and be able to see how the code can actually reflect what's putting out there under the argument that's important for STEM students in order to have some, uh, I wouldn't say necessarily mastery, but to be comfortable with coding and being able to implement that from a scientific perspective. I know that other people in the community feel that AI is going to take that place, but I'm not there yet. So anyways, this is what it's putting together. I'm going to, I've actually already ran this code so the kernel is ready. Many of these things are stepwise in order to help instruct students why you do one thing over another thing. Um, uh, it's probably better for me to, let me just refresh this without a kernel. And I'm just going to initiate a kernel in order to be able to put that in. Each one of these things are meant to be steps. Um, and this right here is the actual widget that's most useful, talking about the wave functions of probability. I can come in and I can basically write this code in order to ask for feedback and then spit these things out. This right again is one of multiple possible technologies that one can use in order to have these sort of engaged widgets out here. But this is the one that gives me the ability to come in and start to edit the actual code and then rerun it. And if I rerun this, I'll probably freak out because I didn't write proper Python code. Yeah. And again, it's interactivity, which is the key point that we want to be able to address here. But in this case here, I can then use this as a mechanism for students to understand about why wave functions are the way they are and start to go through various other questions that we have in order to do them and come up with responses off of here. And this doesn't have to be just in Python. Like I said, it could be any of these languages, R, Octave, which is a MATLAB-like alternative, C++, and such like that. We're basically binding the kernel, the Jupyter kernel, into this page in order to be able to operate. There were a few questions that were in the chat. So let me address this. Bob says, can you create custom environments within the Jupyter? Yes, you can. In fact, when you go into the Jupyter notebook system right here, uh, it will come with Actually, I've already loaded it up. Here are some kernels that we already have, and if I didn't have them loaded up, it will give me some options on there. So we can bring in multiple kernels in order to be able to run different things if you create them and move forward. Right now, Python, Julia, Octave, and R are the core ones that we have out here, and we have some other aspects, other uh, components to it too. It's an exceedingly powerful platform that I can't do justice with it for the period of time that I have. Yeah. Justin already answered that. Okay. So um, unfortunately, I didn't grab the Python code that really is quite beautiful in order to look at. This right here is, again, looking at it as the Jupyter Hub or Jupyter Notebook system on the hub in order to see how the code kind of comes in and you can then modify it and move off it. It's exceedingly powerful. I'm actually very excited about that. And it really complements a need that STEM students need. So, Paul asked the question likely to be answered. Okay, can you set defaults to prevent editing and allow students to adjust in real time? I think so, but I'm not entirely sure how to go about doing that. Um, uh, my use of Jupyter is largely as binder, not as the hub itself, because I want students to be able to interact with these. But other people have used the hub as a direct infrastructure in order to facilitate. And our goal is to be able to take the hub and put it into the Forge so that you can actually keep track of how students have been coding so that when you have issues about students that may have been grabbing AI-based code and paste it into it, it's basically the same thing. We can track it and do the same sort of analysis and pop it out there. To my knowledge, Jupyter infrastructure does not provide that capability, at least right now, out of the box. Bob Belford asked, can a student have their own user directory? They have read-write permissions on the assignment, but not, yes. Basically, that's set up automatically when the student gets access to Jupyter. They have their own infrastructure in place. I think we save the files for if it hasn't been they haven't been touched for something like 3 to 6 months, and then after that we purge them or back them up in some way. Um, uh, uh, Paul's basically asking about revision control behind that, and I'm still at its infancy. I'm not able to discuss that in detail, but perhaps Carl knows more about that, who will be talking momentarily about this. So let me transition back to what I was doing here, which is largely the end of the discussion. We've had, just to summarize, we've had Jupyter within the LibreVerse for the last 7 years. It's only relatively recently that we moved it from a bare metal or basically an on-premises infrastructure into the cloud to give us better control of the infrastructure and better scaling. Um, It has the utility in order to do a wide range of different languages that you can use in order to learn computer science or apply computer science skills in order to do data analysis. So you can give data and work with it. So a lot of data science classes focuses on this infrastructure that Jupyter is able to provide. For example, to my knowledge, the data science college in UC Berkeley uses Jupyter in order to be able to, and they have a wide range of resources that we are in the process of bringing down into our platform so you're able to grab and then run with it and use it in that way. So Bob is basically what I was mentioning that you can harvest Jupyter books into LibreText. Um, I should clarify what a Jupyter book is before talking about that. So the idea behind a Jupyter book is a notebook-based system that's multiple steps, multiple pages. You can actually reformulate that basically as LibreText pages with things embedded, just like that binder page, that page I showed with quantum mechanics, and that's essentially a Jupyter notebook, but as a book series instead of an individual page off of that. And we go through efforts in order to be able to harvest, which is the term that we use for bringing things into our platform that are not created in our platform quite extensively and such. So Jan asked, does this mean that we would be using student work into textbooks? That means you have the ability in order to do so. So both the Forge and the Jupyter does have the one possible outcome of using both of them is to be able to generate open source technologies that you can then integrate back into books in order to be able to move forward off of that. So there are different modalities that one can talk about how to actually bring student constructed content into textbooks, but that requires a bit more discussions of things. Now, in terms of managing permissions, I'm not actually able to talk about that right now. I apologize. I have not fully mastered Jupyter. It's a lot in order to take in. Okay. Any other questions, concerns off of here? I encourage you to play around with it. You have access to it again on the Launchpad. Instructors get free access to it. Otherwise, it folds into students requiring 6-month access is within that $15. And like I said, that there's this bundle, so it's all tied together into one package that's out there. Okay, with this, I'm going to hand this off to Carl Greco from Arkansas, who has been using this a bit and is able to talk about a case study. And I would bet hard money that he knows a lot more about how Jupyter operates than I do. So with that, I'll hand this off um, to Carl, and please take the screen, and thank you very much.
Well, thanks, Delmar. I must admit, I don't necessarily know everything about Jupyter. I'm still learning, but what I've done, I've in the past have used Jupyter Notebooks and Jupyter Lab to deliver material to students and have them make it interactive so that they can use it almost like a textbook. There are several examples where Jupyter Notebooks and Jupyter Labs have actually been used to create full textbooks. But one of the disadvantages of that is that the markdown language that you use in Jupyter Notebooks and Lab is not as powerful as it is obviously when you use LibreText. So what I've done is converted many of my book, or not many, but some of my books to the LibreText with the embedded Jupyter using the binder option. And so I wanted to show you that today. So I'm going to share my screen and let's see. You should be able to see my screen now. So basically, I wanted to start with showing that on our campus, we use Blackboard. And the nice thing about Blackboard is it does actually allow me to import the modules from LibreText directly into Blackboard. So that's what I've done here. I've actually this is my sandbox, so just for development purposes. So I've now uploaded the textbook that I created for my DSP digital signal processing course. And the book is entitled Discrete Time Signal Processing. And you can see it's here a link in Blackboard. So it's actually imported directly into Blackboard. And so I can open this up. And in chapter 1, I want to introduce the concepts of DSP to the students. So what I chose to do was to, let me just load, it'll take a second to load. What I chose to do is use some data, some sunspot data that's readily available, and then actually use a technique to get the spectral analysis of that data. As many of you know, sunspots are periodic. It's linked to the magnetic system of the sun. And as it changes on a periodic basis, about every 11 years, the poles swap from north to south, it introduces sunspots, which are just anomalies of the electromagnetic activity in the sun. And so actually you can see that I've actually included some figures here. And I did that earlier on when I was developing this book, because actually I was having some issues getting Python to run properly. So I wanted to make sure they could see it. But now that it runs properly, I've actually embedded the code to actually read the data directly and then to plot the results, and also find the power spectral density, that was the spectral content of that information, to identify, first of all, the major peaks and also some side peaks that exist. And what this code does is it introduces the student to not only spectral analysis, but also in terms of some other applications that I've introduced to them in terms of digital filtering. So the code is actually much longer than it needs to be. This first half of the code was introduced because I wanted to be able to read the data either directly from the web source or from a local file. And so that's actually not the important part of the code. It actually starts here. And the first thing it does is it just actually reads the data from a local file that's on my textbook. Okay, embedded, actually, you can see it down here. It's embedded here within the textbook. And so this is the file that was downloaded and linked to the textbook. Okay. And then it plots the data, and it also then low pass filters, that is removing higher frequency components from the data, and shows that information as well, which you'll see in just a minute when I run it. And then it also finds the power spectral density to identify what the major frequency content is of that data. Now, this data goes back to 1749, so it's an extensive database, and since 1749, that data has been accumulated as a monthly average of sunspots. Okay, since the early 1800s, it's been then collected on a daily basis. But I wanted to go back as far as I could, so I went back to the 1749, and I'm now looking at it on a monthly average basis. Okay, so let's go ahead and run this. And if I run it, it'll take a minute to load the kernel. Okay. But it should start pretty soon. Where's it? There it goes. All right. So the first thing it's going to do is actually just print out the data in the first 5 data points, first 5 months, basically, and the last 5 months. So you can see it started at 1749, month 1, January, obviously, and up to 2025, month 6. Okay, so it had all the data up to June of this year. And this is the data of the actual sunspot, number of sunspots observed on an average monthly basis in the blue, and then the red is the low pass filter, essentially eliminating some of the higher frequency. So this introduces to the student what you can do to analyze your data to remove high frequency. And then this last graph is the power spectral density. And I use a peak detector to detect where these peaks are located. And you can see that the periods associated with those peaks are 56.9 approximately for this first one, and that's in years. And the next one, the taller peak is at 10.67. So it's known that the periodic cycle of sunspots is every 11 years. So it's actually That's a rounded off number, so it's actually 10.7 approximately. But there's also another smaller peak down here at 5.5 years. Okay. Um, at So every 5.5 years, there's also a cyclic component of sunspots, in addition to the longer period of about 57 years, which is shown down here at this first peak. So this, I think, is a very effective way of using this to introduce to the students. Now, the nice thing about this is the students can actually go in and make changes. So they can go into the code and actually change some of the parameters. Let's just say, I'll just change something. Let me make maybe this figure size different. So I'll make it 10, 12. There we go. So the figure size right now, you can see here is this figure is not quite as wide as the one above it, but I've just made a change so that when I run it again, now it's the same width. So you can see that now as a user, I can go in and make changes to the code. So students can not only see the code and see what it does when they execute it from the book, but they can also make changes. And of course, when they do that, their changes aren't going to be saved. But when they do, they can, test their own theory and understanding of the code by making changes and trying it in real time as reading the book. Okay. I think that's all I was going to have to say. Is there any questions? Can I see the?
There were a few questions in the chat. If you'd
I
like, I can read them for you.
Yeah, I can't see the chat for some reason.
Okay, Bob Belfort asked, when you transfer a Jupyter notebook to LibreText, do you manually do it, or is there a programmatic way, like the way you generate a Jupyter book with Jupyter Book Package?
Yeah. So Bob, first of all, good to see you and see that you're here. And I want to thank Bob particularly for helping me out, actually getting involved with LibreText. So yes, Bob, there's not a direct way of implementing it other than maybe just a copy and paste. And so that's what I typically do. What I typically use is a integrated development environment created by Microsoft called VS Code. And I actually do all my development work for the Jupyter Notebook Python code in that IDE. And then once it's working there, because I use that interactively on my own system. And so once it's working there, then I can just cut and paste it into the LibreText document.
Hmm. Do you use the hub at all, or is everything just binder based in your classes?
I've used the hub somewhat, but mainly I wanted to use the binder so that I could um, embed it in the LibreText book.
And everything you're doing is Python, or have you played with
Yeah,
Octave?
no, everything I've done so far with this is Python. I Initially I started out using Octave, but actually we're trying to transition on our campus away from MATLAB into Python. And so I've been converting all of my code into Python. So I initially started with Octave over a year ago now, I guess it was, but I haven't done anything since then with it.
Yeah, Octave is too ingrained in me after 3 decades, or MATLAB
All
to
right.
switch over.
Yeah, the same thing here. I mean, that's an issue. That's all of our faculty are MATLAB based developers. And so trying to transition everyone over to Python is a bit of a struggle. But
One thing to mention is that the conductor for a project has the ability in order to store assets, and that's more than just PDFs. You can actually use it to host the notebook files for Jupyter. And we are going to be using that in order to host the Berkeley files. So you can just come and grab it and pull it up automatically within that infrastructure.
Yeah.
Okay, well, thank you again, Carl. This was actually
Sure.
quite beautiful. It's nice seeing it in action.